Hi, in the previous video we have seen how to implement the stack abstract data type with the help of linked lists. Now I'm going to implement it with the help of arrays. So I'm going to create a package with the name stack array. I'm going to create a stack. So in the stack.java, I'm going to make it generic first of all because we would like to store integers, doubles, custom objects and whatsoever. I'm going to have the private t stack and I'm going to have the private integer number of items, for example. It's very important that with the linked list implementation, it's very dynamic, because we just have to update the references and keep inserting new items at the beginning of the linked list. Here it is just an array, and arrays are not that dynamic. We have to set the size of the array at compile time, and if we would like to insert new items to the stack, then we have to reconstruct the array. For example, we have to double the size of the array, or we have to shrink the size of the array, so we have to decrement the size of the array. So that's why it's going to be a bit more complicated. The stack is going to have the method. I'm going to instantiate the stack as a t, and I'm going to create new object. For example, for just a single slot. Okay, this is how we are able to do it. We are not able to create with the t parameters like this, for example. We are not able to do so. If you hover your mouse, cannot create a generic array. So Java doesn't support generic arrays. So that's why we have to use the object. But because the object is the parent of all other classes, of course it's not going to be a problem. Okay, then I'm going to have the push method. So public void push with a t new data. Okay, then we can check that if the number of items is equal to this.stack.length, it means that the array is full. So we have to resize our array, and I'm going to make twice the size of the actual array. So the stack.length. So what does it mean? That we keep adding and pushing items to the stack, and if we come to the conclusion that the stack is full, then we are going to double the size of the array. I'm just going to have the stack and the number of items plus is equal to the new data. Okay, so what does it mean? It means that whenever we are going to push an item to the stack, first we have to check whether is it feasible to insert that new item, because we have to define the size of the stack at compile time. For example, we make the size of the stack to be equal to 1 at the beginning. And if you come to the conclusion that it is full, then we are going to double the size of the array. Okay, you may pose the question that why is it good to double the size? And basically applied mathematicians and computer scientists came to the conclusion that this is the optimal resizing procedure. We have to double the size of the array whenever we come to the conclusion that the stack is full. So what about this resize method? Basically, we just have to create a new array. For example, is the stack copy is equal to we have to cast it, and because we are not able to create generic arrays, we have to create something like this. And I'm going to instantiate a new object. Of course, I'm going to rename it. Okay, so we have created a stack copy, and the size of the stack copy is twice the size of the original stack. We are going to double it. Of course, we have to iterate through the I is less than the number of items plus I, and we have to copy the items from the old stack to the new stack. So basically, the stack copy I is equal to this.stack I. So what does it mean? We are going to copy the items from the old stack to the new stack. And then we just have to update the references. So this.stack is equal to the stack copy. Okay, so basically this is how we are able to resize this new array in order to be able to insert as many items to the abstract data type as possible. Of course, we have the public boolean isEmpty method. It is going to return this, that number of items is equal to 0 or not. I'm going to have the public integer size. It's going to return this, that number of items. But what's very important is the pop operation. We have the public t pop. Okay, first I'm going to have the item to pop is going to the this.stack, and I'm going to decrement the number of items. Of course, if the stack is empty, then we are not able to pop off the items from the stack. And another important fact that maybe we have to resize the stack, because let's consider the fact that we are going to allocate an array for 10 million items, and we keep popping off the items, and at the beginning we are going to deal with, for example, 1,000 items. Then of course we have to shrink the size of the one-dimensional array because it's going to waste memory. So first of all, we have to check whether the number of items is greater than 0, of course, but we have to check whether the number of items is equal to this.stack.length divided by 4. Computer scientists and applied mathematicians came to the conclusion that the optimal solution is that we are going to halve the size of the array whenever we come to the conclusion that the number of items is equal to the stack.length divided by 4. What does it mean? That the capacity is 25%. So we just use 25% of the stack one-dimensional array. Then we have to decrement the size of the array, and basically how we are going to decrement it, we are going to make the size to be the half of the original array. So I'm going to call this resize with the capacity this.stack.length divided by 2. We are going to halve the size of the original stack. And of course we just have to return the item to pop. Okay, so basically that's all about the most important parts of stack. As you can see that this resize operation is going to take ordo n, so linear time complexity. We have been talking about the linked list implementation. There, all the operations took ordo 1 constant time complexity, and this is exactly what I've been talking about. This stack implementation is memory friendly. We don't have to store any pointers, we are not going to use linked list nodes and so on. So it is memory friendly, but it's not going to be as fast as the linked list implementation because of the resize operation. As you can see, it is not a constant, it is linear time complexity. It is much slower than the constant time complexity. Okay, and basically because of the resize, okay, we don't have to resize the array on every push and every pop, because if we don't have to resize ordo 1 if no resize, and it is true for the pop operation, it is ordo 1 time complexity if no resize. But if we have to change the size of the stack or the size of the array very frequently, then this implementation is not going to be very efficient, and we have to use the linked list implementation. So let's see what's going to happen. I have my stack, for example, integers. My stack is equal to a new stack. Okay. My stack I'm going to push 10. I'm going to push 100 and 1,000. I'm going to get the my stack.size, and I'm just going to print out the my stack.pop, and I'm going to pop the items 3 times. Okay. So basically, if I run this application, okay, it's a Java application, as you can see the size is 3 and the result is going to be the same as we have seen for the linked list implementation. We just popped out the last item we have inserted, which is the 1000, then the 100 and then the 10. So this is how we implement the stack with the help of one-dimensional arrays as an underlying data structure. Okay, we are going to be memory friendly, but on the other hand, this operation, as far as resizing the one-dimensional array, is going to take linear time. So that's why push and pop method is not going to take ordo one-time complexity always, because if we have to resize the array, then of course it's going to have linear time complexity. For linked list implementation, this is not the case. The linked list implementation is very, very fast. Of course, it's not as memory friendly as the array implementation, but whatever. Thanks for watching.